Okay, well, with that being done, let's switch to our code. So I'll close you up. We'll head into Nature of Code and Rust, Chapter 2. And so we're going to be doing, let's see, cargo new example 2.6 attraction. I think that's what it was. Yes, work done, time to play. Exactly, and time to play with our like updated toys. And then here I'm going to add a folder to workspace. We're in Brooks Builds right now. This is now Nature of Code and Rust, Chapter 2, Attraction. So the first thing we're going to do is let's go grab in the one crate we need. So I'm going to grab you, put you in here, and so we shouldn't need to pull in. Come on, mouse. So I have an old gaming mouse, and it double clicks sometimes, which is fun in games, but it's also fun when like trying to open up shelves like this. Okay, so with you, we're gonna start with our standard opening here. So, the other thing is I want to rename this. So I'm just gonna call this attraction. So BG main, so, attraction. These sizes are fine. Attraction. And that's the end there. We'll create a lib.rs. glib, and so that just comes down to the end. Now we can change this now. So let's comment you out, and I'm going to write the new one. So we're going to say use bb ggez, and here's where we can now say that was an attractive name. Do you like bb ggez? I don't know, like I feel, and sometimes it might be too much, like too hard to say. So we're going to bring in ggez, but we also want to bring in ggez colon, and then it's going to be all of this stuff. I guess I could just pull in you now. Oh, you're referring to attraction? Oh, I didn't even see the pun. Oh my gosh, that is so good. Then you. Oh, come on, let me. Oh, wait, what happened to it? Alex somehow deleted it. There you go. All right, that should do it for that. I need to update the snippet for this. So let's that'll be later. Well, of course I'm going to use it. If we just add it in, let's start using this and like make everything cleaner. Also, now that I look at this, I kind of like the idea of new lining this one. So that way it's just all on individual lines and makes it a little bit easier to read. It's also a searchable name. You found the crate instantaneously. Oh, that's awesome. I like to hear that too. Okay, so let's actually run this. Make sure it runs. Cargo run. Example 2.6. That was one of the reasons why I wanted to do some of the pull requests before the stream, so that I can get those published up there, and then I can start using them. Luckily, Creates.io doesn't have like a really long time between when you publish it and when it's available. Like they don't queue that up, and which is really nice. Then we can just do things like this. In fact, in a way, it takes longer to compile this for running than it does to publish. You need to get your runtime extracted into BBGGEZ now. So what do you mean by the runtime? Like a lot of this stuff? Window creation delta time? Yes, definitely. I think I created an issue. I want to say that I created an issue for doing like the main file, because I think that would be the first step, is to get the main file in there. Man, it always takes this long? Ah, geez. Yeah, create wrapper for... So I think this is... The name needs to be changed. So if it's not going to be a wrapper, it's going to be like an extension. Or abstraction. So... I believe this is an extension as... There, I'll do that. Comment. GitHub is a snail. Okay, so we have 3 errors. So what do we got here? Okay, so that's not an error. Okay, fail to resolve use of undeclared type or module GGEZ. What? Use of undeclared type or module GGEZ. Unresolved import. GGEZ. Oh, this is in the other crates. This is in the other... Wait, this shouldn't be another file. The main library. That's where it is. I need to update here too. Okay, so you are going to be bbggez colon ggez. So we're going to do the same thing here. Bring you down here like that. Comma, so you come out like that. And there. So that should use you, and then we're using attraction. That should be good with that. Unexpected. Okay, so missed a semicolon there. All right, so we got our basic game, and we can move it around. Perfect. So let's go ahead and start. Let's start actually building this thing. So in let's actually go take a look at what we're building. So nature of code, the book. We go into chapter 2. I don't know. I think we're near the end of chapter 2. Yeah, so gravitational attraction. So 2.9. So we got this one and one more, and that will be the end of the chapter. So we're now going to move into space and create two bodies. They're not going to have any forces besides the gravitational attraction to there. Good morning, Katali. You're seeing this without sound. Danny and Alka, you can hear me, right? Because you've been responding to me. Yes. It might be a problem on your end, Katali. We've seen that before with like it being stuck. I mean, I'm at max volume. I guess I could turn the microphone up, the gain up, so that way it will blow out your speakers. But that might not be the best idea. Oh, okay. Not a technical problem. Okay, I totally wasn't thinking about that. Um, so I guess I should just say something like, "Welcome." There. Oh, you've seen Twitch streams with automatic closed captions. I don't know how. I asked someone if how to do that, and they didn't know. But that would be really cool. I would really like that. Okay, so what was I doing? We want to create a gravitational, like a static object that's going to attract. So that means to me it's gonna be kind of like our player object, except it's gonna stay still. So it's gonna be a static. So let's go ahead and create. I'm thinking we'll just call this a planet. And G player. So we have a public struct. I'm going to call you a planet. You can either do it through your broadcaster software and then it appears a CC button on the player controls, or through an extension like stream closed caption or link here permitted, or elsewhere if necessary. I think I have it so you can add links. Yeah, okay. So I'm going to lose my chat for a second while I open that up in a backend and send it to the browser. Hold on. Okay, send you there. Done. Come on. I want you to load so that I can go back to my chat. Okay, so you're loaded there now. Back to chat. What I really don't like about Twitch chat, that I do think that YouTube has right, is when I'm away from Twitch chat, I can't see if any new messages come in and I don't load up again. So in that like 10 seconds, if there is a message, I missed it. Okay, so we have a new planet. We're creating the circle still here in this method, but that's fine. Our next one on Monday will probably, we might be able to have Katali's. So let's see. Now, the planet doesn't need a velocity or acceleration. It does need a mass. They did briefly have old messages load up in chat when you opened a channel through an API request. Oh, interesting. Because I know they're keeping them. And then we're going to have our mesh. I'm not sure if I need anything else in here right now. So let's now create this. So we're going to have our location. We're going to have our mass. We're gonna have our color come in, and then a context. That's fine. We create our new planet, which is a circle. That's fine too. Planets generally are circles. We're gonna fill it in. We're gonna create it as a point and a mass and a color. Then we build it. So we're going to store our location. We don't need a velocity or acceleration. We just need the mass and the mesh. We're not going to need apply force to the planet. And we're not going to need update because we're not going to have it move. We're probably going to have like an attract in it. But so if we want to draw this out now, so in the library, we're going to have just right now a single planet. So we need to bring in mod planet. Okay, so you're going to be our singular planet here. We then have to create a new one. Oh, I keep on putting it in the wrong place. This is you. Planet. And here we're going to do planet new. Okay, so location. So where is it going to be? I'm thinking we'll just put this right into the center of the screen. So we need our arena. So well, that means we probably need our game width. So arena height equals what is it? Graphics drawable size. My auto complete isn't working quite as well. I'm not getting all the errors showing up either, which I know we have some warnings. So that's a little bit disconcerting. RLS really didn't like it when we like switched around to a bunch of different branches. Okay, so that gives us that. So now our location we can set as wait, what did this have to be? Location is a vector 2. So this is gonna be vector 2, the arena width. Okay. The mass. So let's make this, I mean, obviously we want this to be decently big. So maybe like 50.0. Color. So we want to bring in our utility here and store that. So BBGZ. Isn't it utility? Why are you not coming in the way I wanted you to? Because we extern, yeah, so it's just big U. Utility. Okay, so we're going to store that. And then in U, we have our color. So we're going to say, come on, work with me, mouse. Utility. Oh, we need to create a new utility. So dot create. Oh, come on. Random bright color. And then our context. All right, so that gives us that game, and then we're gonna pass in our utility too. And then in our draw, we just want to draw out the planet. So we're gonna say graphics draw. Really, you're not gonna give me the autocomplete that I need here. Cool. All right, so RLS is dead. It does seem to be. Can I right click you? I can tell you to restart. Probably need to restart RLS. Wait, there's no way to restart RLS? Should be a restart. Oh, it's in here. Restart the RLS. Okay, let's see if that works. That was really fast. I don't know if I trust it. Let's try it again. No. Okay. Cool. Graphics draw. What do we need here? I need to remember what it was that we get in draw, and it's not telling me. I need to go to the documentation now. Okay, so it's docs. What is it? It's gonna be draw. Okay, so we need to hand it the context, a reference to the drawable, and the parameters. So context, a reference to the drawable. That'll be self dot planet dot mesh, and then this will be a new point point two from self dot planet dot location. Is that where we're putting it? Yeah, because we're doing 0, 0 in this mesh. So we have to actually then translate it to where it's actually going here. And then we don't really care about anything else. And then we'll present it. So let's see if this works. Expected one parameter in, oh right, context. Goes into drawable size. Color not found in this scope. So that's in the planet. Oh, we have a bunch of errors. Oh, this isn't a planet. Okay, so I need to update this too. I need to update all of the locations to use this correctly. So you come in down here. I don't actually think I need GGZ on its own. So you that and close. That should work for you. Cannot constantly forget that you need to be mutable. All right, perfect. We have our planet. I mean, it's kind of boring. It doesn't do anything right now. So now I want to create another. What a beautiful planet. I need to create another, like a small satellite object. So I guess this could be a moon, or an asteroid, or a spaceship. But they're going to be circles instead. So I don't know what we want to call those, like asteroids, meteors. They're only meteorites if they hit the planet, and I don't have collision detection on, so they're never going to be meteorites. Let's see. So not you in here. Let's create a new file. What should we name this? Is it asteroid? Satellite? We'll do satellite. So gplayer. So satellites. This is going to be fine. Now, what's interesting is that our satellite, we also need to fix you right away. There. So that should be good for you all. We are going to be using a location, a velocity, an acceleration, a mass, and a mesh. So all of the things we're going to use. I'm going to multi-line this for a second. So we have our new function. We're going to take on all of this stuff. We're going to create our circle. Satellite. So we're going to create all of that. This should be fine. We're going to have our apply a force, which is going to be normal, except we're just going to have it attract to here. And then update. Okay, so let's use it. So now this is going to be mod satellite. Okay, so we're going to have a single satellite in here, which means we can now. So satellite, we're going to do satellite new. Hey, now we're getting these. Okay, so location. This, let's put it like, I don't know, midway through, halfway. So this is halfway down, a quarter of the way down. So this is going to be vector to new. Arena width divided by 2.0. Then halfway down is going to be the arena height divided by 4.0. So that should put it right here. Then we're going to have our mass. We created the other one as 50. Let's do something like, I don't know, 15.0. Our color, so this is going to be utility dot random bright color. And then, of course, the context. Just try to get into the habit of doing the trailing commas. Okay, so that gives us our satellite. Let's then just draw the satellite out. Context self.satellite.mesh. All right, so that should draw the satellite out. No, it did not. Okay, so game has no field satellite. I thought I added that. Wait, that's the wrong one to scroll up. Here's satellite, satellite. Oh wait, did I forget? No, here, satellite new. So I'm adding that in there. What are you upset about? This is a live line 5. Satellite, help, a field with a similar name exists. Oh wait, did I capitalize it? I did. Lowercase. Okay, now we have our satellite. So now, of course, here's where like the math part comes in. Turn on gravity. Well, then they'll just fall. I want to turn on attraction, which is that this is going to attract this one. So how does that work? We need to go to the book to remind, because I looked at this entire formula last night, and then I sort of forgot what it was, and I didn't draw it out, which would be nice. But I think what the idea is that we're going to take the mass. So it has like sort of right here. The mass or the masses of object 1 and 2, we're just going to multiply them together. Is that how it works? And then divide by the distance squared. So to calculate the attraction, so I guess we're going to have a function on here to attract all the other objects. We're going to pass this instance into the planet. Is this a multiplication by that r? Refers to unit vector pointing from object 1. Okay, so they have like the full. Oh, they sort of like then go straight into code. R hat is, wait, is that literally just called a hat in math? R hat is for the direction. That's kind of funny. Okay, so the force that we care about, you're pretty sure? That is actually pretty awesome. I like that. Okay, so we need, this is the mass. Oh, okay, so this is also gravitational constant, which we can just make whatever we want. So we're just gonna make it 1. So, all right, so gravitational constant is something in our universe. So because of that, we're gonna store it in the game. And this is gonna be an F32. So let's just make this like 1.0 for right now. And then, oh, I guess I need to, we're gonna pass that in to here. Oh, maybe not at the time. The planet doesn't need to know about it yet. When we do the attract, then we're gonna store that in there. So we're gonna save you. Then the mass of the two objects. So we're now going to go into our planet and create a public function called attract. Let's just do a reference to self right now. I don't think we need to, we're gonna like mutate anything. we need to take the gravitational constant and we're going to return a vector 2. So we're going to take these two so the two masses are going to be multiplied against each other with the gravitational constant. So is that just... Yeah, so look, it's just G, so a gravitational constant times the mass 1 times mass 2. So that's all we need to do here. So the two masses, and then we're going to divide by the distance squared. So this means we also need to take in the satellite. So use and you can be a mutable reference to the satellite. And what are you going to do? We're going to say so we first get this top part, and then we divide by whatever this is, which means we need that. So we have the gravitational constant, we have the two masses. We now need the distance, refers to the distance between the two objects squared. So I guess like, what is that called? Radius squared? So distance. So let distance equals, okay. There's a distance squared function somewhere in algebra. Really, like it actually does the distance squared. It's not just, because that the magnitude is the distance, and then I can square that myself easily. But so what is that going to be? That's going to be our self.location minus the satellite dot location, and then get that as a magnitude. So dot magnitude, and that will get us the distance. And then I just need to square that. So just multiply it by itself. So now this is the formula. So we're going to say, let our force... Oh, and that's just the direction. So we already... This distance is also the direction. We're just going to normalize this vector at the end when we need to multiply it. So, okay, so we can just return this at this point in time. Let's create a new, I guess it's not going to be a new vector. It's going to create them. Highlighter ready again. I didn't tell you to restart. Okay, so this is going to be gravitational constant times self.mass times satellite.mass. We're going to then divide that by distance times distance. Sometimes the connections drops or is told to reconnect via an RSC command. Oh, that's true. Okay, so that gives us this part. And then we need to multiply the entire thing. So I wonder if I should shadow this a little bit. So we can do let force equals and then I'll return our force times, it's not going to be distance dot normalize. That should be our force then. That attracts it. Oh, I guess like I'm not returning. So if I'm attracting, then I'm gonna mutate the satellite, aren't I? So this would still be a let force equals. I'm not going to necessarily return anything. I'm then going to say satellite dot apply force, and the force is going to be our force here, and this delta time. So I need to pull that in too. So I'm not sure why it's like not working the way we want it to. Distance should be a scalar, not a vector. Oh, it is, isn't it? So distance, because of magnitude, that's going to be an F32 now. It won't tell me that. So then we're going to take the gravitational constant. That's an F32. We're going to multiply it by the mass, which is an F32. So these are F32s divided by the distance times the distance. So still working with F32s. Force equals the distance. So this won't work. Oh, I want to grab these. And then, okay. Copy you. So force times you two subtracted by each other. That will give us. I know, RLS abandoned us today. And then apply the force, which has been converted back into. Oh, thank you, RLS. You just told me what I wrote right here. This should now be a vector. But let's find. Oh, and then I need to update the satellite in here. So we apply the force in. We now need to run those functions in update. Okay, so we're gonna say without making it a unit vector, the further away it is, the greater the force. Wait, really? Should be. I guess I don't know what unit vector means. I kind of want to like try it to see what it looks like though. Self.satellite.attract it's self.planet.attract self.gravitational constant, self.satellite, and delta time. Vector with a length of 1. Oh, am I going to have to reverse it? I guess this is where my math skills are very, like, show. So then we're going to say self.satellite.update. And I think that's all I need to do. Then we're just going to draw it out. Let's see if you're correct, and it just gets really crazy strong. the farther away it goes. Expected mutable reference. So yes, I need to give that a mutable reference. Oh, and mass is private. CJ, good morning. Yes. And the highlighter is working. Also, Katali, hello. You can hear us now. We were talking while you're gone about like how we can make it so that people who are watching could like see captions of it. Alka sent me a link, so I'm gonna check that out later. Yeah, the highlighter is really cool. I really like this. I don't know if there's one for YouTube. Let's see. Then what is this? What was I already forgot my error. It's satellite.mass. Make you public. Also, fun fact, CJ, I can't make these go away. You have to make them go away for me. Now what am I missing? Field mass of struck satellite is private. Wait, I made that. Didn't I make that public? Wait a second, I put it in the wrong spot. You don't go here. You go up here. Well, okay, so let me run this, and then I'll show you how it's supposed to work, Alka, and then how it actually was working. I mean, so it looks like it got attracted, and then it just sort of went off. Okay, so here is. Wait, where was that? Oh, you already took it off, Katali. So if you add it on, they don't end up here. They don't show up. So here this is. If I now come to highlighter, it's not. What? Okay, never mind. Before it wasn't actually like available for me to remove, and now apparently I can remove them. So that's cool. Cool story. I'm not crazy, I promise. Okay, so it got attracted and just went off into the abyss. Let's give our satellite a little bit of initial boost. So I'm thinking we do want to give it a velocity of like to the right. So we're gonna start with the x is maybe like 5.0, and then 0.0, so it's just going purely to the right, and then it will hopefully circle around the planet. So I saw it flicker and then it was gone. You think it takes more effort to find an orbit? So that it was there for like a microsecond and then bam, I just disappeared. I don't know. That feels like odd. That do I need like less? A lot less. We need like something like 0.1. There we go. Take a look at this. So I think it's working the way we want to. What frames per second is it playing at? That's a really good question. I don't know what I can do to really like get that to check. But I mean, this is pretty cool. We've got this working. The book then does say that we want to limit it. See where that is. Constrain. Okay, so if we go into like the exact middle, we're going to have like an entire really, really large number, and then it's going to just zoom out. Ship it. I mean, it's kind of working, so that's like, this is probably more shippable than some stuff I have. Well, it's a wobbly orbit because I gave it like only 0.01, so it wasn't enough to get into a truly circular orbit. Will it ever crash into the planet? I mean, it's possible that it might. I don't have friction, so it won't like slow down. Looks like the atom logo. A little bit, yeah. So it's suggesting that we constrain the distance between 5. Oh, the distance between 5 and like 25 pixels. So let's see what that would be. This is going to be in our attract. So that's in our planet. So after we calculate the distance, so let distance, I guess I want to create a new function for this then. Does an algebra have docs and algebra? Is there constrain on here? Oh no, it just got there when I gave up. Okay, so is there a constraint? Constraint, compatible constraints between, no, I don't think that's, okay. How about a vector 2? So you're based upon a vector n. Maybe it's just my internet that's slow today. And look here, it's getting longer and longer and longer as we go, and I think that's my what is it? The delta time sort of being a little bit off. And so I need to figure that out. Or maybe just not use delta time. Katali, off-topic question, should I create a PR with my implementation of the new file system to BBGGEZ? I mean, it can't hurt. Because like, what's the worst case scenario is we decide we don't go with it, and then I would just close the pull request. So I would say like, why not? Let's see. So we have methods, vector n. So what do we have here? Constraint. Oh, that's a module. That's not. A type used in where clauses for enforcing constraints are multipliable. Oh, okay. So that's not what I think it is. That's not what I want it to be. I don't see any methods on here. So I think I need to implement this myself. Unless, of course, there's something here and I just don't see it. So let's create a constrain function. And I guess this might be a good sort of like something to put in to the something to put into the utilities, because like this is not necessarily something related to a satellite. Okay, so constrain is going to take in self, which I don't really care about, and it's going to take in a vector, type of vector 2. And we're going to just return a new vector 2. Do I want to turn the new vector 2 or the same vector 2? This, I mean, so like if this is functional, then we're just returning a new vector 2 of f32, and I'm not really mutating it. And so I'm going to just return vector 2 new. Let's do 0.0, 0.0. It's like to set it like that. And then what I want to do is just have an if on here. So if vector dot x. So if that is, oh, I guess I need my constraints too. I guess right now, because it's just a magic number in here. So if it's less than 5.0, or vector dot x is greater than 25.0, unexpected open on line 32. Do I have an unexpected open line 32? I don't see that. Open curly brace. I don't have a curly brace open either. Oh, it's just okay. I thought you were using a poem to tell me where there was a problem in my code. I thought that was gonna be that was gonna be really clever. So I read into it way too literally. sorry, Dark Reaper. And also, good morning. Okay, so we can constrain that. So if that, then I guess like we can't really do the or here because we need to know which one we're going to do. So if x is less than that, then we want to set then vector, I guess our new vector 2, we need to store this. So let result equals, you need to be immutable. So result dot x is equal to 5.0. Else result dot x equals vector dot x. Oh man, this is, I already don't like the way I'm doing this here. Like this is gonna be a lot of if statements. I kind of like the idea now of just taking in a mutable vector to this and not returning anything and just mutating it, because I think that's going to be less code on our part. And so I don't need a result anymore. Now I just need to say, okay, so if the vector.x is less than 5, we're just going to say vector.x, set that to 5. Else if vector.x is greater than 25.0, vector.x, set that equal to 25.0. And then we're going to repeat this with the y's. And so I think that should work. We now want to, in between here, I think you should be clamping the distance, not the xy components of the vector. Oh, wait, the distance. Oh, wait, you're right. Because distance is an F32. I totally was forgetting about that. You should be calculating. I already have the magnitude. I wasn't even thinking about this. That's just like very so. What am I doing to myself? Okay, so we could just do this as an if. It's like this is not going to be a vector. So we're just going to take in a value, or I'll just take in my distance, which is an F32. You can use min, max, or the algebra clamp function. Wait, there's a clamp function? Wait, this one, partial clamp. Clamp value between min and max returns none of value is not comparable to min or max. So it takes in whatever type value, okay, and return, it returns an option. So we need an if sum that. Okay. Returns none if value is not comparable to min or max. So I think it's going to be comparable. Check the other one. Yep. I think it's my computer. It's being like all of its web stuff is being slow, not just GitHub. Okay, returns a reference to the input value clamped to the interval min and max. So value min and max, and returns the same type. In particular, if min is less than value, it returns value. Okay, that's kind of what we want. So ineligible clamp. So up the top, let's bring in clamp. Yeah, that's just a function on here. And there's no, yeah, it's just a function. So we don't need this constraint. That was a bad decision to go down. So we're gonna distance, we're gonna shadow distance equals clamp. We're gonna take in distance. We're gonna take in 5.0 and 25.0. I think that's all we need to do. Fortunately, RLS isn't telling us if it's working or not, so we'll find out with this. I mean, so that's kind of working. It's a lot faster than I wanted it to be. So that's cool. I wonder if I need to change my initial masses here. Or if I need to change my initial, like I'm moving 0.1 to the right. What if we put it back to like 1.0? Okay, so a lot closer. It's still going really fast. Can you normalize your direction vector before multiplying it? I believe I can. So let's see. Inner planet. Can we normalize our direction vector? So force times self-location. Oh, you're right. We do need to normalize this. The r hat. I wonder if that will run first, or if I need to like wrap that in parentheses or do this in two different lines. All right, so we're back. We're back to the 0.1 being way too much. So let's fix that again. We'll do 0.3. Okay, 0.3 is still too much. We'll just do 0.1 again. That ain't no moon. And here we go. This is a lot more stable of an orbit. So, I mean, we have a satellite orbiting. So that's pretty cool. Now the delta time is not correct. And I haven't figured out how like to make it correct. I know, Danny, you've worked with delta time a lot. Coding Garden, what you do is, oh, you logged in. Okay, so CJ, you were logged in CJ, and now you're back with Coding Garden. So this is pretty cool. Now, I'll leave this on. I've got some time because it's Friday and I work from home on Fridays. So I'm thinking that we'll just do the next example straight up in here and just make a whole bunch of them, which should be pretty easy. In our lib, instead of just a single satellite here, we're gonna have a vec of satellite. So and I'm gonna call this satellites. Satellites equals a new vec. And let's now for loop through. So for, I don't really care, in 0 dot dot. Let's do like 10 of them. And we now want to put the satellite, this code, gonna make this big so I can see it all. So we're gonna start by saying, not in there, in here. Also satellites.push. Before I forget, we'll make this mutable. And we're gonna take the satellite new and put that in here. Now this is telling it where to go, so we kind of want this to be a random location, don't we? So that might be something good to have also. So I'm gonna put. I need to create a note. So random location on screen. That's going to be something I'm going to add in as an issue into the library, so that way we can do that later. Okay, so satellite new. We do need to bring in rand, and we don't have this. It's like re-export rand too. So re-export rand. Does it allow for strange orbits, or will its opposite side be the same distance away, always from the center as the other side? It should be the opposite. So it should be like, it's just pure math of orbiting around, so it shouldn't be a super strange orbit. From what I understand from the math, but I could be wrong. Okay, so what were we doing here? We need to bring in rand. So cargo.toml. Rand in our library. So rand prelude. And then rand create. And then here, so in our arena width, let's just put this as like a purely random number. So rand gen range between 0.0 and the arena width, and oh no, not that one, and gen range between 0.0 and arena height. Okay, so that's random break color, so that's cool. And then I'll push those in here. We'll then just have satellites. What was this? Oh, this is you from a while ago? I don't see. Okay, you're just taking it off. Okay, so you should be fine. Now we need to go into satellite and tell you we need to bring in get the brand prelude in here. So we have the let mash case, then rand create. I know this is like not the best users. I could just pass. Let's just do that. We'll just pass a reference to rand. So RNG is a mutable reference to wait, no. Thread range. I think that's what it is. And then in here in velocity, we're going to use rand gen range. We want you between like 0.01 and 0.2. And 0.01, 0.2. And then in the main library, we need to pass in this range as the last thing in here. Mute RNG. Okay. Let's see if this works. No, okay. No field. Oh, right. I need to update my draws and updates too. So down here on update, we have the planet attract, so we need to loop through. So for satellite in referenced to self dot satellites, we're now going to self planet attract, hand it the gravitational constant, and hand it can I just do this? We want mute, and we want satellite, and the delta time, and then we want to tell the satellite to update. And then in here, we draw the planet, and then for satellite in satellites, we're going to now draw all of you. So satellite.mesh, satellite.location. Okay. Create 1,000 random satellites. Most of them will fly off into the abyss anyways. Well, let's try this first to see if it even works. And then I'll try 1,000. All right, so that's working, and they're all going to sort of like go around in a circle now. I mean, kind of a circle. They're not going off into the abyss, but they are definitely. Oh, because like it's wherever it started. I started with the size of this. So even if I make this full screen, the planet is actually going to be wherever it was. But we could try. So now that we know that that works, we could try making 1,000 of them just to see if my computer crashes. The max clamp on distance probably does that. Yeah, I wouldn't. I'm not surprised. Well, it runs, but it's very slow. You know, something else that we could do that might be a little bit more interesting than creating 1,000 of these. So we could just create 25 of them. But what we can do is in this mass here, we'll just do another randgen range between 0.5 and like 30. So we could have a really big one too. I think this will be more interesting. Also, too many of them are not starting moving, so we need to change that too. So our initial movement in a satellite is just not enough. So this velocity, we probably want to change this between like 0.07 and 0.2. Want to go negative? Oh, you're right. You're right. I do. So negative. So negative. How about this? 0.1 to positive 0.1. Wait a second. Wrong one. You hear negative 0.1 to 0.1. And I could put this at negative 0.2. Positive 0.2. All right, let's try this. There we go. This looks so much better. I guess I was initially thinking that they all should go in the same direction, but this one is like, they'll just go wherever they will feel like. But this is it. We've now got an attraction. I could make this center one a random dark. circle. So that way everything else will draw on top of it a little bit better. So that is our main library. Here is our planet. Where's our planet? So create a new one. Planet, random dark color. Oh, we don't have that in there yet. Did I not? I thought I created random dark color. Yeah, random dark color. There. And now it's a little bit easier to see all of our other planets sort of on top of it. And that's attraction. So I think that's pretty cool. We barely got done in the time frame that I have. So I'm gonna go ahead and get this all set up. So all of you, so created a bunch of satellites orbiting. I mean, orbiting is a very big question here. I don't think they're orbiting very well. It's not very stable. I could like implement where they hit, they like crash and burn and die. That might be interesting. Orbiting a bunch of satellites, orbiting a planet. And I'm going to push that up. Because we're in Hacktoberfest, this is like doubly true, but for all of my stuff, if you want to make like a challenge to like change something about this, like for example, have them hit the planet and they disappear, have like start with one and have new ones start off the screen and come in. If you want to like fork this code, implement that, then feel free to like pull request that in. Even if I don't like, I might accept that pull request, or you can put it onto a different branch as like an example, or we'll just leave it there as like other people can go check out. Or you could just take a GIF of that and tweet it at me. That would like those would all be pretty awesome to sort of like see. You want to see the line paths drawn as they move. Okay, well, see that's another challenge to do. I'm not going to implement that right now. So I pushed that up. Let's go grab the code and I'll share it out with you all. So nature of code in Rust, it is in chapter 2. Traction. Here's all the code that we worked on today. And so here is a link to that. Feel free to play around with that. Check that out as you will. If you're watching the VOD, I'm also going to put the link in the description so you can find it later. With that, I don't think I have anything else. I think this is pretty much going to be the full. This is the full challenge for this. If that one's a little bit odd. It like I thought it was gonna turn in a little bit more, but I guess its velocity going forward is too strong. I need to figure out what my the problem that I have with the delta time. So I might do like some research on that. But if any of you have any ideas of what I could do to make that better, or should I just turn it off and stop trying to like use delta time? That might be another option altogether. But with that, I am going to switch over to the stream ending. So 4. And I hope that you all have a great rest of your day. I'm going to go get ready for my work. And the next planned stream is going to be on Monday. I do these on Monday, Wednesday, and Friday at 6:45 a.m. Mountain Time. But I might do some keep. You can follow me on Twitter for when I do like a random stream. With that, have a great rest of your day, and I'll see you next time.